Have you ever wondered how things like this are made? And I'm not talking about the 3D models themselves, but rather how they are textured. Or this? Or something simpler like this? How about this? This can be done using a technique called texture painting. Let's take a look. There are different ways of painting 3D models. There are tools like ZBrush that let you sculpt 3D models and paint right on them. Blender also lets you directly paint your assets. However, I want to show you a technique that is not dependent on a single tool and that also teaches you how the underlying mechanism for texturing 3D models works. Furthermore, this technique gives you control over each and every pixel on your model and allows you to leverage skills you may have in image editing software such as Photoshop or Krita. For this video, I will be focusing on how texture painting can be done using Blender and the open source image editing tool Krita. In other words, how to do this with tools that are freely available to you. When you model a 3D asset, you usually end up with something like this. An untextured object that is more akin to a sculpture. Now how can we apply a texture onto a 3D object? Obviously, we can't open up our 3D model in an image editor and expect to start painting on it. Image editors work in 2D space. They allow you to manipulate two-dimensional images. So the first challenge is, how can we map our 3D object onto a two-dimensional space so that we can paint it in our image editor? Luckily, this problem has been solved for us by some smart people long ago. The solution is something called UV mapping. You can find definitions of what UV mapping is readily online, but what it basically is a way for us to map locations on a 3D object to locations on a 2D image. So what does this mean in practical terms? Can we ask ChatGPT to do this for us? I guess not. Yet. Think of UV mapping as unwrapping a gift. The gift is your 3D object and the wrapping paper is a 2D texture. So the first step in texture painting is unwrapping that gift. How nice, right? This unwrapping is called UV unwrapping. The result of this step is a two-dimensional representation of your 3D object called a UV map. Let's look at a simple example. Let's look at how we can UV unwrap this cube here so that we can later paint a texture over it. Just like we cut through the wrapping paper when unwrapping a gift, we have to cut through parts of our mesh in order to start unwrapping it. To cut through our mesh, we place what are called seams along the edges of our mesh. In this case, let's cut our mesh into 3 parts. The top, the part that loops around the middle, and the bottom. Now let's unwrap this and see what happens. In the UV editor, you will now see these 6 squares. These squares represent the faces of our cube. This is our 2D representation of our cube. This is our UV map. A 2D representation of our 3D object does not help us much when we want to start painting it if we don't know what part of our 2D representation corresponds to what part of our 3D object. So the next thing we want to do is we want to turn our UV map into a sort of geographic map of our object. What I mean by that is that we should know, by looking at our UV map, what parts of the map represent the top of the 3D model, what parts represent the sides, and what parts the bottom. This will allow us to paint the different parts of our mesh to our liking. The 3 parts of our mesh, the top, the sides, and the bottom, are present in our UV map as well, and each part is represented by a separate UV island. We can pull these islands apart from one another a bit to make it obvious that they refer to different parts of our mesh. By hitting this toggle here, Blender allows us to see which island represents which part on the mesh. This allows us to look at our UV map and know that this part is the top, this is the middle, and this is the bottom. This geographic map of our mesh is also known as a UV atlas. Now that we have our 2D representation of our mesh, and we know which parts in our 2D representation correspond to which parts on our mesh, we are ready to start painting. We can take our UV atlas and export it to an image. We can then import this UV atlas into our image editor of choice. And now we can start painting. We know that this part of our atlas corresponds to the top, for instance, so we can paint the top of the cube yellow. We can give the middle section a nice blue color. And finally, we can give the bottom a nice shade of red. If we apply this texture to our mesh now, the colors we painted in the various parts of our UV atlas will appear in the corresponding places on the mesh. Understanding the idea that a given location in the texture maps to a point on the 3D model surface is exactly what UV mapping is all about. What I showed you here is the most basic example of how to paint a texture onto a mesh. As your models become more complex, this process will become more challenging. Choosing how to place your seams is one of the most challenging aspects. This will depend on a multitude of factors, such as for what parts of your mesh you want to have a seamless texture. You also want to make sure that you place your seams in such a way so that the resulting UV map is not warped. You also want to keep an eye on how you use your texture space. You can check out a short I made about optimizing texture space if you want to learn more. So that is basically it. I hope you enjoyed this, and I hope you got a basic level of understanding of how you can paint your 3D objects. If you enjoyed this, don't forget to like the video and subscribe to the channel. Thanks!